So the agenda is I will start with providing a quick overview about HoneyBook, just so you have the background for the engineering work. And then I'll discuss the first stage of this solution, which is around how we generated lead responses in real time with AI, still without the personalization part. In the core part of the talk, I will talk about how we used feature stores to personalize these responses. And then if time will allow, I will talk about some lessons that we learned along the way. So a quick overview about HoneyBook. HoneyBook is an all-in-one platform for small businesses in the US. These businesses are usually more service-oriented. So our typical users, or as we like to call them, members, are business consultants, doulas, event planners, every type of business that has a fundamental part of client communication in their operations. So we provide them with capabilities that are relevant to them. For example, project management functionalities, financial management functionalities, and most importantly, probably the client communication functionalities. So we give them white-labeled contracts, invoices, automations, and I think one thing that is probably most important to this talk, we provide them with an integration to their website contact form and also to social pages contact form. So what does it mean in practice? If I am a member of HoneyBook, if I have a HoneyBook account, I can integrate HoneyBook within my website, and whenever, let's say I'm an event planner, okay, and someone wants to book an event from me, so if they enter my website, I have a new lead, like they fill all the information, what is their email, phone number, some other details about the event, click submit, and voila, our member has a new project in HoneyBook. And they can use all the functionalities, which include a very simple corresponding communication. That means they can write emails within the product while using our functionalities. So when ChatGPT released, it's almost 2 years ago, we decided that it is the time for us to provide with some generative AI capabilities to our members. And the most natural step for us was to give responses ready for them in real time. So what does it mean in reality? Whenever they have a new project, they get a notification, hey, someone is interested in having a project with you. So what we did, we also told them, and we also have a custom-ready response for this lead. So if we have, for example, this lead where someone submitted, someone is interested in having an event or a project with a budget, with an email, some details about the project, what our members see is a notification plus this custom-ready response, and they have the option of changing the tone, making it longer, shorter, like changing some other tone from a list, and send the response. This experience is pretty straightforward, I think, to anyone who uses generative AI, probably to this audience. But it wasn't very trivial to implement this architecture in mid-2023. And let's talk about the architecture for this first version. And again, this is only the first version without the personalized tone. So what we do basically, first of all, we have the event of someone submitting inquiry, which was discussed. Then the information in the inquiry is transmitted with in a Kafka event into our microservice. We are working on with microservices architecture. And within the microservice, there is the data science code, some call to a large language model. In our case, it's GPT-4, which I will elaborate in the next slides. And then there is a response, which is sent into the product. Now, let's talk about each of these components separately. First of all, the inquiry submission. So we had this architecture beforehand, and this was one of the motivation for us to choose this use case. We had the integration, we had the Kafka event with all the relevant information. So that was like a very, very important motivation for this decision, for going with this feature. It is important to also mention that in the Kafka event, we get, first of all, the inputs of the client, right? Everything that I basically showed, but also some metadata about the member, about our user. So it's the company info, company name, business vertical. All these things can serve us when we generate the prompt to the LLM. The model serving or the input within the, that gets the Kafka event is a SageMaker endpoint. Now, why did we choose to work with SageMaker? It's not because, it's basically because we had a comparison between different vendors, and we already worked with AWS, regardless of the location of this conference. So we decided to go with SageMaker. It basically served everything that we needed. There was like the consideration of the fact that you usually need to, you usually have like 60 seconds until you can get, you have 60 seconds where you can have a SageMaker process running. So that was a consideration that it wouldn't take too long, but it was okay for us. Okay, so when we have the Kafka event with all the relevant information, the next stage is the data science module, the data science component. So we had to conduct some data processing. First of all, we don't need everything that in the inquiry. We don't need missing values, because then you can see that the GPT like says in the response, hey, I saw that you didn't mention the budget, which was mentioned in the inquiry. So that was like a passive-aggressive approach that we didn't want GPT to go to. And also, in general, we didn't want to mention money in the response. So that should be excluded, because even if you specify in the prompt that you don't want this information, it can happen very frequently. Second thing that is important to mention in this regard is that we use GPT-4 in production. Now, as a reminder, we're talking about mid-2023. Most of the companies didn't use GPT-4 in production, and we decided to do it first and foremost because this was a push mechanism. It wasn't a case where some user like created a prompt, pressed submit, and had to like wait for a long time to get the response. We had the control of when our users will get the GPT responses, will get their email responses. So whenever they got whenever we got a new project, we had a couple of seconds between having the project until sending the notification along with the GPT. So the notification is waited to the GPT finish, until the GPT will finish its process. So that was another important part. And what you see on the screen is what I call pseudo prompt. The real prompt is really, really long. So we just talk about the relevant component. You are the business owner of a company name, and then there is the company name injection coming from the Kafka event that operates in, and then there is the company type injection, because this is also an important context. You got an inquiry with the following information, and in the inquiry injection, you have the processed data, right? Not like the raw inquiry that we got. And then there is the task specification, which is very general to all inquiry responses. Okay, and after that, we get a response, we send it to the product. We store the result in S3, and it's not only the responses themselves, it's also the response time, what was the stopping reason, also the cost, of course, so we can analyze that. Everything from S3 is then integrated into our analytics database, so our analysts can analyze the performance. And basically, the most important aspect of analyzing the performance is comparing the results to the actual response. So in our case, we chose Levinstein eddy distance as the measurement. We could like choose different things, but that was a fair benchmark for us to keep improving this model, this solution, sorry. And I think more importantly, we added within the product the option of user feedback. So users could basically thumbs up and thumbs down to the responses that they got. And when they thumbs down, they could provide us with the reason for thumbing down. And that was very, very useful for us, along with interviews that we conducted with users. And before diving into the feedbacks for thumbing down, I would say that it improved the booking conversion of our members. We saw more bookings for them, which is important for us because this is our business model, basically. The more they book, the more we earn. So that was good. But we did get these following user feedbacks, which I think that all of the audience here can relate to. They said that it doesn't sound like them, people that didn't like the responses. And this one was very resonated for us. I don't like this cheerleader ChatGPT tone. And we all know this feeling when we coming to ChatGPT, we have some email thread, we give the email thread. Now we have some general guidelines for the response. We ask ChatGPT just write the response, and it writes something that looks beautiful, looks amazing, but it doesn't sound like us. We don't feel like it represents us, and we won't use it. Now you can say that we can give some more guidelines. I want it to sound like that and this and that, but eventually it will be probably more efficient to just write this email, right? So we had to solve this problem on a larger scale, right? There is dozens and even hundreds of thousands of members that use this feature. So we had to give them this very, very efficiency, this efficiency on a scale. But the challenges for giving them the writing style is, first of all, how can we model the writing style? Right? I mean, this is, again, something that should be at scale. Second thing is that writing style cannot be provided with a Kafka event. In the Kafka event, we provide some very specific, very specific information that is related to the event, right? Like everything that is in the inquiry itself. We don't have very complex information, so that should be created offline some way. And third point is that writing style may change over time. So we have had to make this writing style changing and not being static for each member. So the solution that we came with, which is our V2, is to use feature stores. Now, I think that most of us know the concept of feature stores as a tool for us to make sure that training data and inference data are aligned and consistent and available for data scientists and ML engineers. But we viewed feature stores as also, we thought that feature stores are also prompt injector stores. And that was the general approach. More specifically, we wanted to consistently store information about the user in a batch process and then use this information in real time for generating new responses. Now, let's talk about the architecture that enabled us to do it. Before talking about the architecture, the actual process was that we had to save for each of our users in offline, but in accessible way, some tags that represent the writing style. So one thing was to run this process offline and make it updated on a periodical basis. And the second part was to make this data or this information available online, right? So this was exactly the thing that we used the feature store for. So what is the process? First of all, let's talk about the process of the feature store ingestion, how we can take the text from the product and make sure that they are in the feature store in the right way. So we have the HoneyBook product. The data or the information in our case is all the correspondences of the member, the past correspondences. We want to use them to assess the writing style. We take these correspondences, we have some, and this is basically in MongoDB or whatever in-product database that you use. And the first stage, we want to load it into our analytics database. So data scientists and data analysts can analyze it without affecting the production data. So we use Fivetran as our ETL tool. Basically, it's for extract and load. Read the data into the analytic database. And right now, it's in its raw form, right? So not all the correspondences are relevant. There are some automatic responses there. Some responses were actually coming from the client and not from our user. So we have to clean this data, to remove personal information, to remove everything with names and things that are not relevant. Keep probably only inquiry responses and not like other responses that came in the remaining of the thread. This is done with a data transformation tool called DBT. Basically, in this tool, data scientists and data analysts can write their queries, take the raw data, and convert it into a table that is designated for their own task. In our case, for creating the writing style. Now we have the relevant information of the writing style within the database, but that's not enough because in production, we cannot access the database. We want to have something in between that is accessible, but also sort of mirroring what we have in the database. So for that, we use a feature store. Again, the SageMaker feature store. Again, we already worked with AWS. We already work with SageMaker for our serving, and it made most sense for us to keep working with SageMaker, and we could understand the feature store that they provide. The feature store is basically, the way I understand it, and maybe I'm wrong here, it's an abstraction level above DynamoDB, above like in-memory DB, where you have key value storage. So the key in our case is the user ID, and the value is the text that represent the writing style. So we write the relevant data from our database schema to the feature store using Prefect. Prefect is an orchestrating and scheduling tool that is like parallel to Airflow, which I guess most of you are familiar with. And in the feature store, basically, we have it available online. Now, this process, as you can see, it runs on a daily basis or other periodical basis, depends on how we define it. And then let's go back to the data science microservice. When we want to access the feature store, we can just import the feature store module, which is something that we developed and maintain internally. We have some functionalities there that we can read the feature store. We can choose which feature group. Feature group is like, in our case, is the user correspondence. We can have feature groups for different use cases. Our use case is the user correspondence. So we can, and now if we have some user ID, this is text that like represent a given user ID, we can just get the relevant features, the relevant user correspondence for this user ID. 2 lines in Python that actually gives you the relevant context of the user. Most of the work is done behind the scenes, developing this API and implementing the architecture that I showed on the previous slide. The resulting pseudo prompt, is what you can see here on the screen. The first part is the same, all the stuff that we have about company name, company type, and inquiry injection. And the different part is here. Below is some information about your writing style and tone. Then there is a style and tone injection, which is basically a text that represents the writing style of the user. And then there is this task, which also the task includes some information about how to consider and how to treat the writing style. So first of all, we saw some additional increase in booking conversion and reduction in response time. We saw that 30%, we saw an increase of 30% in the number of members that responded within 24 hours, which we know that equals more bookings and more money for them. We also got some buzz in social media. People said that the new composer generates response that sometimes sounds better than them while still sounding like them, which was great for us. This is exactly what we wanted to achieve. Some learnings, if time allows us, some learnings from this work. So first of all, I showed you the icons of Azure and OpenAI. We have the calls, the GPT calls to Azure. At the beginning, we worked with GPT-4. Okay, we still we no longer work in GPT-4, but back then, when we wanted to work with GPT-4, we saw that we got some errors in production. We saw that in some cases the response time was actually not something that we can tolerate. So we tested the option of working with Azure. We ran an A/B test where the models ran in shadow mode. Again, because it's a push mechanism, there wasn't like we had real users that submitted and waited for the response to come. We generated the responses, so we could run the two models on shadow mode. The same solution, basically, one with an Azure call with GPT-4, and the other is with the call directly to the OpenAI API, and Azure was better for us. Second point that I want to discuss, what's the right time for fine-tune or train your own model? So today we don't have GPT-4 in production. Today we fine-tuned our model with GPT 3.5 based using labeled data, not labeled, but training data with GPT-4. Like we give actual context, ask GPT-4 to generate response, create like thousands of those, and send it to fine-tune in OpenAI, in Azure OpenAI. The reason for that is that as we scaled and we saw that costs starting to accumulate, it made more sense to move to a fine-tuned model. So I think that our message here is that you might start with the best model and then like solve the accuracy problems and think about the right place to scale it. Third point is about OpenAI versus competitor. I think that also something that all of us can relate to is that people always tell us, oh, you're using Claude, why don't you try Llama? Or you're using Llama, why don't you try GPT-4o? This is like endless and keep updating every week. We're working with OpenAI basically because we don't have the time to check every week all the models, although we do try to do it. Right now, the thing that keeps us with OpenAI, honestly, is that they have the best API. So of course that I want to have the best model, but it's more important for me to have a valid JSON as a response than having like the best response. So this is for now, and this might change, and maybe I'm already wrong, but for now, this is the reason why we keep with the OpenAI. Last thing that I want to discuss is developing with feature store in mind. So the feature store, as you can see, was created as the last stage of this solution, right? Because we don't have everything that is needed on mind, and it's basically a production concept. So it's pretty hard to like work with the feature store before it's even existed. So what we do right now, when we do develop a new feature, we treat our database as a feature store. Like we call it with some SQL queries. And then like when we need to move our code to production, we just update this specific code, adapt it to have feature store instead of SQL calls. And basically that's it. I want to thank the team that actually worked on it. I just represent the team. Sagi Toval, Noam Shalev, Shai Brumer, Michal Barer, Doron Partov, who sits here as well, and you can ask him questions. He would probably know to answer better than I, and Nimrod Milo. Thank you very much. Any questions? Yeah. So we keep, the question was, what's in the feature store eventually? I mean, what text we have about the user, right? It's text. It's just a text that from that we can like give it to GPT and tell GPT, this is something that represents the writing style. It can be a frequent lingo, it can be some representative sentences, something like that. It's a context, yeah, sure.
Great, thanks.
Thank you.
Thanks.